Question number 2. The equation for the reduction of iron ore in a blast furnace is given above. So part A, how many kilograms of iron can be produced by the reaction of 7 kilograms of iron oxide and 3 kilograms of carbon monoxide? So first step, we would have to convert 7 kilograms and 3 kilograms to grams in order to get how many moles of each. So to do that, we would take 7,000 grams of iron oxide, multiplied by 1 mole over the molar mass of iron oxide to get 43.835 moles of iron oxide. And doing the same with the 3 kilograms of carbon monoxide, changing that to 3,000 grams of carbon monoxide, and it will be multiplied by 1 mole over its molar mass of 28.01 grams to get 107.105 moles of carbon monoxide. So now that we have our moles, we're going to do a ratio. So we would start with our iron oxide, and we are trying to get to iron. So we would do a ratio of 1 to 2 and have it equal to the molar mass of iron oxide, which is 43.835, have it over X because we are trying to find how much moles of iron we can create from the iron oxide. From that, we get 87.67 moles of iron. All right. And then we would have to do the same with the carbon monoxide to the iron. So that would be a ratio of 3 to 2 equal to the molar mass of carbon monoxide over X, cross multiply to get 3X is equal to 214.21. And then we divide both sides of the equation by 3 to get 71.403 moles of iron. Now that we've found how much moles of iron each one of these reactants can create, we can see that the moles of iron from the carbon monoxide have a much smaller number than the moles that iron oxide gave us, so that is our limiting reagent which we will be using to find how much kilograms of iron can be produced in this equation. So we would take 71.403 moles of iron, and we got to convert it over to grams, so we would take its molar mass, which is 55.845 over 1 mole, and that is equal to 3,987.5005 grams. The question is asking for kilograms, so to change it to kilograms, you need to just move the decimal place over to the right 3 places, and you get 3.987 kilograms of iron. So that is how much we can produce when we apply our limiting reagent. Part B, how many kilograms of the excess reagent remains after the reaction has ceased? So this is going off right where we left off in part A. We are going to take our limiting reagent of moles of iron, and we are trying to find how much grams of iron oxide we have left over after. So to do that, we would have to multiply 71.403 moles of iron times 1 mole of iron oxide over 2 moles of iron, and then cancel that out, and then we multiply it by the molar mass of iron oxide over 1 mole, so we can find how much grams of the iron oxide were left over in that. And then the question is asking for kilograms, so we would move the decimal place 3 places to the right, or the left, excuse me, to get 5.701 kilograms of iron oxide. And going back to part A, we had, in the reaction, we had 7 kilograms of iron oxide. So we're just going to take what we got in that equation, subtract it from the 7 kilograms, and from that we get 1.299 kilograms of iron oxide. And that is how much was left over of our excess reagent after the reaction was completely done. So part C is asking what kind of reaction is this? So this isn't really a particular reaction that we learned about in class, like the 5 types, like a combustion or synthesis. Basically, to put it into more of like a realistic way, when iron is like mined, it often contains like a trace amount of oxygen, which is like iron oxide, which is part of our actual like question asking when you put it in a blast furnace how much iron ore you have. So what they do, yeah, is basically they put it in an environment where it's very hot, and from this they get pure iron and carbon dioxide, which is exactly what happened in our equation also.